Good morning, everybody. Welcome to another fun day. CS 202. It's nice and sunny outside today. Maybe pretty soon we can all be walking around on campus again. We're a little bit early here, so as always, we'll give some people some time to hop on the stream here. If anyone is in the chat, if you've started the assignment, do you guys have any questions? You can go ahead and ask them. I will just mention last class. I did run into a seg fault. I don't know if you guys remember that. Probably do. And I ran into a seg fault, and I couldn't figure out what it was. And if you had to go, I'll tell you what the fix was. In this parameter constructor here, I had declared this as an int size. And so whenever I was referencing size in here, I was referencing this size and not this size. And so at the end, I think when we got to this part, we had a for loop in this operator, which was referencing this right-hand side size. Now the size never got set. And so it was some super large garbage value. And so it would just infinitely go until it either seg faulted because it tried to dereference some null address here. And stuff like that. So all I had to do was take away this silly little mistake that I made, so that we were referencing the correct size, and everything was fixed. Of course, that video is on YouTube, so you can go experience it all again if you'd like. No cost to you, except for your time, of course. So it is 11:30, so let's go ahead and get started here today. Today we will be finishing up this string class. And I've got my notes off to the side, so we should not run into anything like this. I did have notes last time, but I do get carried away sometimes. But today we will be moving along here, moving forward. And we're going to do a few more operators. The main ones we'll focus on today is we did the multiplication last time. So let's just quickly take a peek at that. And so recall that we're just going to take a string and multiply it by 3. So what we had to do was increase our size. We had to make a brand new array. And we had to make that new array 3 times the size. So then in these double for loops here, we just copied over loaf, or whatever the string is, 3, or whatever the integer parameter is, that many times. And we just fill in that brand new array. And then, since this operator, as any multiplication operator usually does, it returns a new type. So in this case, it will return a new string. And so I had to declare a new string. I had to assign the size. I had to assign the new array. And then I had to return it. And so we tested this. So if you ever want to test this, you take a string times some integer here. We also overloaded this one, which is just the swap of it. And I didn't test it, but I know it will work. So I'll just come down here and we'll change it out here. So this is the other way around. If we did an integer first times a string, and that will just work the exact same way. We did a nice little cheat here, right? Look, I just swapped the right-hand side and the left-hand side, which we'll just call this same function. So this is a nice little cheat that we got going on here. On top of that, we did the assignment operator. We've done this a few times already in class, but just a quick refresher for that. Recall that the assignment operator happens when we do something like this, and we need to overload that assignment operator because we don't want any memory leaks. We don't want to create any shallow copies and anything like that. So this is when the assignment operator gets called. And so all we have to do is delete our old array from the left-hand side, right? Which is the this object. This is the left-hand side. We have to delete that old array, and then we have to deep copy everything from the right-hand side. So that's all you ever have to do for that. And then I showed you this nice little trick here. When we do the copy constructor, why don't we just use the assignment operator? Because we use the exact same code. So I could either copy this section into here, or I could just call it. And how do I call it? Well, I need to get a string CS202 on the left-hand side. And so really I could just take the pointer that points to this object. I can dereference it, so now it's a string CS202. And then I can just assign whatever this copy is to it. And all the exact same code will work. Especially if we initialize array to be null always. Then when we call delete down here, it won't matter whether or not array is null or if it actually had some values in it before. Of course, we did our destructor. And we did this kind of parameter constructor, right? Where we look for the null terminated string. This stuff's not on any tests. But if we were to make a string class, this is how we would do it. If we were looking at a character array. And we did the default constructor. So do you guys have any questions about all that stuff we did last time? Because we're just going to jump right into it. And we're going to finish up our operator overloading today. So today, we did the assignment already, and we did the insertion operator already. We did the multiplications already. So today we will do an addition operator. This is going to be the concatenation. We're going to do brackets. Brackets are super easy. We're going to do this one. This is the extraction operator, and this one's a little more involved. But only specifically because we're dealing with strings, which deal with character arrays. Strings really make our lives easy. And before strings, we had character arrays, which really made programmers' lives hard. So I'm just going to kind of show you how we can get that to work. And then on top of that, we'll probably do just an equals equals. This is a Boolean, right? We could also do a less than equal or a greater than equal, but mostly they're kind of the same. You'll just compare the characters, you know, as you scan left to right. And you can return true or false based off of if they're less or greater. Lesser or greater. So we won't do these, but we will do the equals equals just to show you how that works. And then lastly, we'll open up a file, and I'll show you how to do plus plus and minus minus. We're not going to do plus plus minus minus on a string. We could, but it doesn't really make much sense. Instead, I'm just going to give you another example. And this will help you with your assignment, because we haven't discussed how these work. And if you've used them before, you always have the option when we have int g equals 0, if we can do a g++, or we can do a plus g. So we can actually overload both of these operators. They're considered to be two different ones. There's the post decrement or the post increment, which is that one. And then there's the pre-increment, which is that one. So I'll show you how to do that. And that'll be it. So please stop me if you're confused or have any questions. And we're going to go ahead and jump right into it. So the first thing I'm going to do is I just want to bring in our file streams for our files. Because I recently went grocery shopping, and I figured that we could read in my grocery list into our strings here to show you how that operator works. I'm going to move Loaf's water onto the ground here so she'll stop bothering me during class. And let's go ahead and get started with that. So what does that look like in general when we call the... Let's go ahead and put some comments here. This is our multiplication operator. Multiplication operators. These are our... We call these the insertion operators. Now this is an insertion operator because we're inserting to this O stream. Okay, so think about it in terms of the stream and not in terms of the object. This might be considered an extraction operator because we're extracting from the string, but instead we're actually inserting to the O stream. There's our assignment operator. So those are the ones that we've dinned. So now we're going to do a new one, which is going to be the extraction operator. And so we're going to do a few things. For one, we'll go ahead and into, say, you say string s up here, you see that? So let's go ahead and C into that, just like we normally would. And then we can also make a file stream, right? So this one is an input. Remember that I stands for input. So that's our input file stream. We'll call it our in file. And I'll just show you what we're working with today. This is just my little shopping list. All right, so it's just a text file that looks like this. And so if we were to be reading from this file, we would read in breakfast with a colon, and then we would read in this dash. Then we read in coffee, and then we read in this dash, and then we read in apple, and then we read in sauce, etc. So that's what we're going to work with today. We're not going to do anything fancy, like asking for the file and stuff. We're just going to hard code it into our code here. So this is our shopping list. And then what we can do is this. We can say while in file. Right, and so here we are calling that extraction operator again. Into S, we can go ahead and see out our S with an end line. Does this make sense? And when we're at the end here, we'll close this. So usually when we do an insertion operator, we also always do an extraction operator. It just makes input and output very easy for us, especially when we're defining our own classes. And so I'm just going to look at my notes here because I want to make sure everything's good and we don't run into any seg faults and things are looking great. So let's go ahead and get started with that. So I like to copy this. Recall that, well, let me ask, let me type it out here. Can this operator, which is the extraction operator, can it be a member of the class? What do you guys think? This will be our left-hand side. Has to be global. Yep, thank you. Thank you for entertaining me. That is correct. It has to be a member of the global. And so this is very common. I'm using this left-hand, right-hand side thing like I always said, which is always good. But you can always do something like in. That's very common as well. In and out. In this case, this might be out. but we won't change it up too much here. We'll just keep that one as that, and we'll keep this one as the left-hand side. And then we're going to have our string CS202. Now recall that we're going to actually read into this object, right? We're actually going to be reading something into this object. So we have to make this a by reference. We have to say, hey, this is a reference, because we're actually going to be altering this object. And then the next thing we need to do is make sure that they're friends, right? So we'll just copy this function here, this operator overload, and we'll bring it up top. And we'll just put it in our class, friend, and we'll put it there. So now we're good to go. And we have access to these two parameters here. These not parameters, members. We have access to these two members. So let's get started. And so we're going to be seeing into some stuff here. This is kind of a complicated operation here. So I'll ask you guys for some intuition here. So I told you that when we do a string literal like this in C++, the compiler will add a null character to the end of this literal here. Without us even knowing about it. It will add that. And that's how we know how to stop, right? So when we were in our parameter constructor, which is right up here, right? Constant, this is a character array, right? And that's just a pointer. We look for this this null character to know how big the string is and when to stop. Now with the cin, we're in the same issue. In which, when do I know to stop reading from the input? And we have to look for some characters. And do you guys have any ideas of what some of those characters might be? And if you have some ideas, I'll go ahead and put them down. But in the meantime, I'll let you know that we will be reading in a character one by one here, because we are dealing with a character array. So I'll just prepare that. Then we're going to put a little while loop here. And this is going to read in char by char. Yeah, there's a good one. Yeah, 3 of you got that. So that's definitely one of them. Usually the end line character is a big one. Also, the space works as well. And a tab works as well. So there's actually a whole bunch of them that we should be looking for. So we know when to stop reading in to this string here. And so there's a cool function. I'm just going to show it to you, and we're going to use it. You don't have to know this function for any tests. This is just for your reference. Here we've got this function called isSpace. Okay? And all this does is it returns true if the character is considered to be a white space character. And so it will return true on a space, on a tab, on a new line, on a vertical tab, on a feed, and on a carriage return. So it'll always return true on these. So this is a nice function that we're going to use in our overload here. So let's go ahead and put here in a comment. These are white space characters. Now there's one thing that I want to do. This string already exists, right? If this string already exists and we're going to start reading something new into this string, do you guys have any ideas what we should do first to avoid any memory leaks? Because this string might already be something. You know, this could be loaf or patty for all we know. So if we wanted to avoid any memory leaks, do you guys have any ideas on what we should do about that? Remember that that string has its own character array in here, and it has its own size. And we've done it quite a few times already. In fact, we did it in the assignment operator. Yeah, I like that. Red Rose has got it. Let's just, let's make sure it gets deleted. So if we go in here and we say, hey, if right-hand side array does not equal null, let's go ahead and delete that. Okay, so we'll go ahead and delete it. And let's also make sure that the right-hand side size is reset to 0. Okay, so this will avoid memory leaks. And then we're going to reset the size of our string. Now this is going to be the temp character to read into. And so here's what we're going to do. In this while loop, we're going to do two things. First off, we're going to take left-hand side. Now recall that left-hand side might be a cin, and it also might be an in file. And so common functions that are used with that is you've seen getLine before, and you've seen get. Now get is the proper one to call here because get will get every character that it sees. GetLine, however, will read up until it sees a certain character and then stops. And so get will be grabbing every single character. And so when we use get, we're going to be able to see that /n, we're going to be able to see that space, we're going to be able to see that tab. And so what we're going to do is we're going to call left-hand side get, and we're going to store whatever that is into the temp. So whilever we're going to be reading from the stream, and then I'm going to do an and here, and I just want to make sure that we're not at the end of the file. So all I'm going to type here is not left-hand side .eof. Being extra safe here. Okay. And I'll kind of separate these out. So this will read into the character, and this will make sure that we're going to stop whenever a file has ended or a stream has stopped providing any input. Yep, so that's looking great. And so now, let's go ahead and do our check. So recall that temp is going to check to see if, well, it's going to grab every single character. So here we could do something like if is space temp. So if this is a white space character, then let's just go ahead and break out of here. Break. Let's also assign this array to null. I kind of went out of order there, but I forgot to do that. And I always tell you guys to do this. It's important. So make sure we avoid a dangling pointer there, because I will be calling delete on this thing multiple times. All right. So if we read in a white space, then we're just going to break out of this while loop. We're going to say, hey, we didn't read in anything. But if it's not a white space, we can do an else here, or we can just keep going, right? Because the break will take us to the end of the while loop. We know that we've read in some character. So guess what I'm going to do? I'm going to do kind of this same stuff over here. You remember in the multiply operator, whenever I want to declare a new array to store a character, and if you remember from the dynamic array that we did a few weeks ago, we made that very inefficient insert function. Do you guys recall that? In which we would declare a new array, we would allocate it, we would then copy all the elements over, we would then put in that brand new character at the end. Well, actually, I just had an idea, but let's go ahead and continue on with this. So we're going to be just doing the same thing here. Now, if we had declared, I just want to point this out. If we had declared the concatenation operator, we might be able to do something like this, where we say this is equal to this plus, say, a new string CS202 in which it takes in some character here, G. And so if we actually had overloaded this operator, we might be able to reuse a lot of our code here by just kind of assigning our object by appending just one character onto the end of it. So I always want you to be thinking about that, because it's very helpful. But in this case, we're not going to do it. So the first thing we need to do is make a brand new character array. And it's going to be equal to a bigger character array, right? So allocate array of bigger size, just like that. And then we got to copy everything over, right? So what we're going to do is we're going to say for int I is equal to 0. We're going to say I is less than size minus 1. Recall that I had incremented it here. And this is the right-hand side dot size. Recall that. It's up here. And this is going to be the right-hand side dot size. And this is going to be the right-hand side dot size. So recall that I incremented it. So I want to make sure that I don't go out of bounds on the old array. And so then we're just going to copy over all of the old elements. Just like that. And then lastly, at the very end, we'll take new array size minus 1 is now equal to our temp character, right? Add end character, or add red character. And it's going to be the right-hand size again. Right? Does that make sense? And so this is just going to keep going. We have to make sure that we delete our new array. Not our new array, but our old array. To avoid memory leaks, right? And then what we're going to say is right-hand side array is now equal to the new array. Just a little pointer assignment there. And so for every character that we read in, we're just going to increase. We're going to make a new character array of a bigger size. We're going to copy all the old elements into it. We're going to insert the brand new element. We're then going to delete the old array and assign the new array. Just like that. Do you guys have any questions about this? I know that this is kind of involved, but we need to be familiar with doing this kind of thing, especially when it comes to dynamic memory allocation. If any of you guys are typing out any questions, I'm just checking to make sure that my code is clean, and we should not have any issues here, and we should be able to test it. Oh, and last thing we need to do, look at what this operator returns. It returns the stream, right? So we got to return this left-hand side here at the end. Just like that. And there we go. So let's just test it out. And I've already kind of typed the code for this here. So I'm going to put an end line here. And let's just kind of talk about what these are. That prints loaf. This prints patty. This will print loaf. And this will print nothing. It should print nothing. Empty string. And so this one gives us loaf, loaf, loaf. S2 gives us just Patty. S1 times 0 gives us empty string. And this will give us, I'm not going to type it out, but it's going to give us Patty, Patty, ... Patty. 10 times, right? And then it'll print out an end line, and then it's going to wait for us to input something. So we can type in whatever we want. And then we'll go ahead and print it out because I want to see what it is. And then we'll go ahead and read in the shopping list. And it will print that out. So let's go ahead and take a look-see. Where am I? I'm here. So compiled. Here you can see all of the print statements I talked about. I guess this is loaf instead. I wonder if I probably just got myself confused a little bit. Yeah, we're doing an S1 here. So this gives us loaf instead. If we made this S2, then it'll be Patty. So now it's going to wait for us to input anything. So we can type in something like Porsche. And when we hit enter, woo! Of course, it jumped ahead on my shopping list here, but you can see that it printed out. So we overloaded that operator to be able to take input character by character. And then I opened up a file. I opened up a file here. And then I just read it in one by one and printed it out one by one. So it does look like it's getting some blank spaces. I wonder what they are. But apparently the white space is not working for that. But you can see we get breakfast, coffee, dash applesauce, eggs, and it's working pretty well. So before we move on here, does anyone have any questions about that? And that was the hardest one that we have today. So we kind of got the hard stuff out of the way, and we can move on to the easier ones. For your assignment, you do have to overload this operator, though it is definitely not this involved. It is definitely not this involved. The only reason this one is a problem is because we're reading into a character array. In your assignment, you're only going to read into 4 integers. So you know exactly how many times you have to read in. But in this case, we don't know how many times until we see a white space here. So this code will go up on Web Campus, and you'll always have this to reference. And so we check that off the list here. See extraction operator. Now let's do the brackets. What do you guys think this? Well, first off, where does this one go? Is this a global? Is this a member operator, or can it be both? Well, if you're ever lost about that, you can always check the notes. And recall how this one is called, all right? So if we've got a string, x, and then we call it, we say something like cout x brackets. Does that give you an idea? What is on the left-hand side? Is there anything on the right-hand side? And because this is on the left-hand side always, just like the assignment operator, this one has to be a member function, okay? And so we can actually I'm just going to remind you guys that it's here. And when I ask you this question on the test, it's right there. So this bracket operator has to be member function. It's super easy. Can anyone give me an idea of what you think it returns? For example, if we just had a regular string that we've been working with for years, string x equals, Bob, and then we print out x located at 1, what does this operator return? Is it returning a string? Is it returning something else? Is it void? Let me hear your ideas. Yeah. Awful got it. A character, right? It will be returning just one character. Exactly. So we know that this has to be a member function, so let's just put it in here. This one is super easy. Bracket operator. And so all we have to do is type character here. And then we're going to do an operator. Now let's actually return this by reference. And I'll show you why. Takes an int index. So we actually want to return the actual location of this character in the array, because sometimes we want things to work like this. So let's go ahead and talk about our bracket operator here. If we've got, what are we looking at? Let's probably just play with Patty here, which is S2. So if I say something like S2 2 is equal to a new character 5, or something like that, I want to be able to access the actual element. And then when I print not only S2 located at 2, I'm going to see that 5. But also when I print out S2 altogether, I should see that that 5 has replaced. We should see that that 5 has replaced, in this case, it will be the 0, 1, 2. It will have replaced the T. And so we should see PA5T for pasty. And so we'll be returning this character by reference. As I said, that's what that and sign is doing there. And this one's super easy. So let's just say this. If the index is less than 0, or if the index is greater than or equal to the size, then let's say something like indexing error, string class, and then we'll exit 1. Now, I just want to point this out. Some of you guys put exits in your code. And unless I specified that we're doing error handling, I would prefer you to not use the exits and rather to just return something from this function. So just in general, the rule of thumb, exit used for errors. And we're returning 1 because otherwise main would be returning 0 at the end. And 0 means OK, which is the exit success. But in this case, if we happen to index out of bounds, instead of segfaulting, we'll just go ahead and exit here with a 1 to tell the user that this program did not exit correctly. Especially if a process is invoking this CPP file, the process will then know that it failed. So here we check for our indexes. Things seem to be okay here. So if we don't exit out of this function, this operator, then all we have to do is this: return array located at the index. Does it make sense? Recall that these brackets dereference the array, right? So it will dereference it, and it should return just that character. So let's go ahead and test it out to make sure things went well. And so we're just going to be testing with our pasty string here. And if I could do one thing real quick, I am just going to comment out this stuff. Because I don't want to see my... I don't want to see my shopping list again. Okay, let's go ahead and give that a shot. All right, do you see how it worked here? I mean, obviously, you know how this works. We've used brackets with strings before, and I'm just proving to you that this operator worked. And so you have to operate, or you have to overload this operator for your assignment as well, this one. So you can use this as a reference. And this is super helpful. This is super helpful. Because guess what? Now we're going to do, let's say, the equals equals operator. So let's do equals equals. How's that called? We'll just say if S2 equals equals S1, then cout same string, right? Else cout different strings. So let's go ahead and do that one. This one could be either. So let's go ahead and make it a friend. Friend. Well, what does this one return? It returns a Boolean. And then it's an operator. Equal, equal. And what's it going to take? Well, it's going to take a string CS202 left-hand side and a string CS202 right-hand side. Just like that. So this one's pretty easy. If the strings have different sizes, then we know they're not equal. So I'll return false. Say, hey, these strings are not the same. Would the operator be a const? Well, we could try it. This one won't. But we could try this one. No, in fact, this one cannot be constant. And the reason is because we're returning this character by reference. And so, kind of by definition, we are returning the address of something within our object. And so if I make this const, it's going to be like, hey, that's not cool. And the reason that's not cool is because you are literally returning an address from inside of me. You know what I mean? So this one is a no-no. But maybe the Boolean. So maybe let's do that one for fun, since you asked. In fact, I'm going to take this out. And let's just do this as an example. Instead of making this a friend, let's actually just make it a member function. Because I said that we could. It could be either. But recall, if we make it a member function, we don't have a left-hand side because that's the this, right? So we'll just delete that left-hand side, in fact. And whenever we want to reference that left-hand size, we can just type size like so. Or we can say this size, right? If you want to be picky about that. You know what you could also check is if we pass this in by reference, we could say if this equals the right-hand side, the address of the right-hand side, then they're the exact same thing, right? So here we'll check for same object. Here we'll check for same size. And then else, we know that the sizes are the same. Now this one I think can be a constant because we're not going to be altering anything. Let's go ahead and make that one a constant as well. And this should work. So we'll try to compile it anyway. Yeah, no problem. Because this one won't be altering to this object. It won't be doing that. And so now we just got to go through a for loop, right? We got to check character by character. So we'll say for I is equal to 0, I is less than some size, right? If the sizes are the same, it doesn't matter which one we use. And then we'll just do some checks in here. We'll say if the array located at I does not equal the right-hand side array located at I, whoops, then we can return false. But if we happen to go through this entire for loop without returning false, then we can return true. So we didn't return false, so they're equal. And then the compiler might get mad at you for this. I don't think it will. But in this case, I think you can just return true or false. Let's do false. This line of code should never execute, obviously, because we have this else statement here. So are there any questions on that? Let's test out my work here to make sure I know what I'm talking about. So we're going to check to see if S2 and S1 are the same string or not. We'll also check for a few other things. We'll check for S1 equals S1. They should be the same thing, right? Because they have the same address. And then we could even make a string CS202S4. Let's go ahead and call a copy constructor on, say, S2. And then we'll do this nice check for S2 and S4. And so what we should see is different strings, same string, and same string. Nice. Worked well. And what do you know? We got it. Works good, guys, right? Makes sense? Just kind of a lot of coding going on here, right? But nothing out of the realm too complicated. And we proved that this operator, especially if it is a member of the class, where is it? This one. It can be constant. Why did I check in 3 different ways to see if the strings are the same for the equals equals operator? Well, I'll tell you the way I think about it, but you are welcome to do it a different way. So what I'm checking for first is the easiest possible checks that I think about without having to do this for loop. And so if each string is 1,000 characters long, this for loop is literally going to execute 1,000 times if the strings are exactly the same. And so are there any indicators that the strings might not be the same before we go through this for loop 1,000 times? And so the first thing I check for is their addresses. So if they're the exact same object, then I don't have to... And, you know, if I could even remove this, because this check will get it as well, right? This is kind of meh. But I just check to see if they're the same object. If they are, then let's return true. And then at this point, they're not the same object. And so I'll just check their sizes. And if the sizes are different, that's just one check. Then I know that they're not the same, and I'll just return false. And so at this point, the sizes are the same. And they are different objects. And so now at this point, I'm like, all right, I got to go through these character arrays one by one. Because I didn't bail out early. Are you okay with that response? Truthfully, this is kind of redundant. I could absolutely delete that. Because I'll probably catch it on the size portion. Well, actually, no, that is not correct. Because guess what? If I removed this, I would end up going through the for loop. And so, in fact, I'm saving myself the most amount of work possible here, you know? So I'm just saving some computer cycles, that's all. But in the end, you could just do this, right? But you have to be careful. Because recall, if the arrays are not the same size, you'll probably run into a seg fault here. Or you'll go out of bounds on one of the arrays. So you always want to make sure they're the same size before you start, you know, picking and choosing characters out of the arrays. So now that that's good, let's check what other operators we have. We did the Boolean here. We did the bracket. So now we're just going to do a concatenation and we'll be done with this string class. And we can finally move on from this terrifying bit of code. How many lines of code have we written? If we're counting white spaces, looks like almost 200. Wow. All right, so the concatenation one will be pretty easy. We'll just kind of go ahead and get started on that. And we can use... well. Actually, there's one thing that I want to mention real quick. Notice that I overloaded this bracket operator. Notice I overloaded this bracket operator. And so this will work exactly the same. Is that confusing to anybody? Instead of using the array itself, I actually am calling the bracket operator. But remember that I need to have an object on the left-hand side. And so in fact, this should do the exact same thing. And let's go ahead and check it. Why not? The point I'm just trying to make is if you're overloading operators, try to use them, you know? Try to use them to make the other operators easier. Ha! Now this is complaining. And the reason it's complaining is because it's a constant function. And I'm returning these things by their address. So we'll go back to the way it was. We will go back to the way it was, but as long as I remove that const, we almost got it here. Oh, right. And I get rid of this const. No constants, we can use the bracket operator. So hopefully that kind of makes sense. But like I said, we'll go back to the way it was. Just because I don't want to be confusing. And it's good to have this example of a constant operator. So in this case, we won't use that, but we'll just do array. And we'll do the right-hand side array. Okay. So finally, let's move on to our final operator. This will be the concatenation operator. Concatenation operator probably returns a string CS202. Operator plus. And what does it take? Well, it takes probably this string and a string on the right-hand side. This text is just a little bit big for me, so I'm going to bring it out just a little bit. You guys can always tell me if the text is too small. So I'll put it anywhere. Those are the multiplications. Those are those, so we'll put it here. And I'm just going to kind of full speed ahead on this one because it's kind of the same as the other operators that we've done. And so just so you guys can see what it looks like, if you recall, loaf plus patty will equal to loaf patty, right? And so if this string is size 4 and this string is size 5, then we need a string of size 9. So we'll say int new size is equal to the left-hand side dot size plus the right-hand side dot size. Let's then make a new character array. Character new array is equal to new character of the new size. And then we just have to copy over the left-hand side and then copy over the right-hand side. So we're going to do four. We're going to do 2 for loops. This is going to be the left-hand side string. This one is the easiest, where we'll just say int I is equal to 0. I is less than, we're going to say the left-hand side dot size, right? Because we're just going to copy, in this case, so we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to copy in the L, and then the O, and then the A, and then the F. So that size is 4. And then we're just going to say new array located at I is equal to the left-hand side array located at I. And now we got to do the right-hand side string. This one we have to use a little bit of our brains here, because now we got to put P in the 5th spot. So what we're actually going to say is, where did we end up here? We ended on the left. We ended on the size of the left-hand side. And so in fact, if we say I is equal to left-hand side dot size, we will be right in the correct spot. And we can say I is equal less than to the new size, right? Because then we're going to go to the end of the string. And then we'll say new array located at I will be equal to the right-hand side array I, and I'm going to say minus what? Do you guys have any ideas? I'm trying to get this P here from the 0th index into the 5th index here. So I've handled number 5, or in this case number 4. This is going to be index number 4. So what can I subtract from this I? Yeah, that's exactly right. Nice job. That's exactly right. I minus the left-hand side dot size, right? That's exactly right. So that will grab the P located at 0, and then the A located at 1, and it will kind of put them here at the end. And so finally, we'll then make a new string CS202. Why not? This will be our return string. And in our return string, we'll say that this array is equal to our new array. And we'll say that the return string dot size is equal to the new size. And then we'll go ahead and return it. And that's it. And that's it for our string classes. So let's go ahead and test it out. Make sure things are working. That's our concatenation array, so we'll just do a cout S1 plus S2. That's all we're going to do. And we'll finally move on from this nightmare. So S1 and S2, I think we'll see loaf plus this pasty string here. Hopefully we don't get any seg faults. G++ ./a.out loaf pasty. Okay, so that concludes our string class. three sessions later. All right, we started on this before spring break, and now we're finally done with this string class. Hopefully it's making sense what's going on here with all of these operators and how they're used, right? I'm kind of putting in the comments here. How do we call these operators, how they're used, and then how we're working with them inside of the class, right? They're just like functions. So if you've got those questions, throw them at me. But we're going to move on to a simpler example, and then we're going to be done with operator overloading for the semester. At least until we do a review day. And at least until when you finish with your assignment, that is. Future assignments, by the way, will probably have some operator overloads in them, such as the bracket, because they make life easy for us. So this one is going to be, we'll do post pre.cpp, and that's what we'll call this one. All right, you gotta move. Get out of here. So this is not going to be a very, how would you say, kind of real life example. I just want to show you how they work, and it will tell you how they work for the assignment. So what we're going to do today for this one is we're just going to make an integer class, okay, as opposed to the literal, the primitive type int, int. And so all I'm going to say is that this integer class has an int, okay? Like I said, not very, this class doesn't have very much use, you know? But it doesn't matter. So we are going to overload some operators. And what are these operators? We are going to do integer, let's say, I. So we're going to do an I++, we're going to do a ++ I, we're going to do an I-, and we're going to do a -, I. So if these have names and you want to Google that stuff, this is the post increment, this is the pre-increment, this is the post decrement, and this is the pre-decrement, okay? So those are the operators that we're dealing with. Now I do need to add what we do today with these in the notes, so I will be sure to do that. And so I'll just show you how we do that. Now these can be both members or globals. So we'll do the increments as members, and we'll do the decrements as globals. So in the public, well, let me ask you guys, what do you think that these will return? Just off the top of your head. We are overloading them, so we can make them return whatever we want. But using intuition and your knowledge before, when we've got an int I is equal to 5, and then we do things like cout I++. Yes, exactly. Now, in this case, I'll give it to you. I want to return this specific integer. But you are thinking correctly. I'm being confusing here, right? It's an int and an integer. But that is correct. So in these cases, we're going to return some integers. We're going to type in this operator. And we're going to do this ++ thing. Now this is what I need to add to the notes. How do we tell the difference between the post and the pre? How do we tell the difference between the post and the pre? And it's kind of silly, but this is going to be the pre. And this is going to be the post. Now, the way that they can tell them apart is that this takes a dummy int parameter. And that's literally what it's called. And that's it. And you know this is a dummy because you don't even have to give it a name. You don't even have to give it a name. You literally just put int in here. So let me pull up the notes here. I'll probably end up moving. Nah, it's okay. So we'll just say the post decrement and post increment operators take dummy int parameters. Okay. So what does that look like? Well, that looks like type. We'll say class type operator plus plus. And then if it's a member of the class, then it's going to take an int here. If it is not a member of the class, it'll take the class type, say object, and it's going to pass it by reference. And then we'll take this dummy int parameter here. So this is the global definition, and this is the member definition. Okay? And like I said, we're going to do both of them real quick. So these are the member definitions, right? And like I said here, I put it in the notes. It's right there, right? So we just did that one. And so what does the pre-increment do? Well, it increments the value, and then it returns the incremented value. Right? So all we're going to say is x plus equals 1. Now, I could use the plus plus operator here, but I don't want to be confusing. So we'll just say x is plus equal to 1, and then we'll return this. Right? In which we increment first, and we return the incremented number. So now I'll ask for some class participation on this one. Do you guys have any ideas? This one will increment the object, but returns an integer that is not incremented, right? So this operator will increment the this object, but it's not going to return it incremented. It's actually going to return an integer that is 1 less than the incremented value. And so I can't return this here, right? Because I know that I want to do this. But if I return this, then obviously I'm going to... Obviously, I'm going to return the incorrect implementation of this operator. Now, I want to do this, but this isn't okay, right? That one is not okay because we're going to return before we even get to increment it, right? Does that make sense? So the only option we have is to make a copy, okay? Now, take notes for your assignment. Take notes for your assignment here. We have to return a copy. So the first thing that we're going to do is going to say integer r, or copy, is equal to this. Fair? And then I will plus equals this integer, but then I'll return the copy. Make sense? So now I'm actually going to copy these two. Let's just do the decrements real quick. we are approaching the end of class time here. So I kind of want to full speed ahead here, just so I know we have enough time. So these are going to be the minus operators. And recall that these are going to be globals now. These are going to be globals. And so I need to pass in the integer. And guess what? It has to be by reference, because we will be altering the object. And this is the post decrement. Oh, I did this wrong. Whoops. Increment, right? I'm kind of taken out. That's okay. And so like I said here, it's taking that dummy in parameter. If I want to check the notes, here it is. Look, now there's that one, right? There's that one. So in this one, I'll just say x minus equals 1. And I'll return this. In this case, I'll make the copy. I'll say x minus equals 1, and then return the copy. Are there any... in this case, this won't work, though. You're right. You're right. You caught me. We're going to return the object. And in this case, we're going to say the object, right? And then we got to say object.x, because it's not a member function. Yeah. Red Rose has a great question, and I will address that in a moment after I put this in. So, Red Rose, that could work if you wanted it to. But what is this? When we dereference this, what does it become? It becomes this integer class, right? And so now the question is, have we overloaded the plus operator? Does that make sense? Because the way that you have it there, it would be an integer plus an actual int. And so we would have to overload the addition operator to do that. And we could. We totally could, right? But it makes sense that way. And that since this is a class, we would have to overload this addition operator. Yeah. We would have to overload it. But we could definitely do that. Yeah, we could definitely do that. And I like the way that you're thinking. Because we can use operators that we have already coded in our other operators to make life so easy. So I really want you to think about that when you're doing the assignment. Is everything okay here? Yeah, it is. All right, so we're just going to test this real quick. I am going to kind of wave my magic wand here a little bit. I'm going to do one overload here. Okay, I'm going to do an insertion operator overload. And I'm going to put it here. And all I'm going to do is print out that object. That's all. That X. And then I'm going to copy into main, and then I'm going to send you guys on your way. All right, so I've defined two integers here. They are the same, right? Except one is the class that I made, and one is the actual literal, the primitive type. And so I'm just doing the exact same operations. And so we will see, this should be 3, because this is the post. And then this will be 4. And then this will be 5. And then this will be 5. This will be 4. And this will be 3. Okay, they should be the same. And they should work. And then you've got all of these examples to help you code the assignment. Post pre. And it looks like I've made a small error, and that error is that I call a parameter constructor here. And if you guys are interested, notice here. It's private. Did I not make them friends? I didn't make them any friends. Yeah. There's a few things I did wrong. I'm getting ahead of myself. For one, I have to make them friends. Because these ones are globals. And for two, I need to make an integer parameter constructor. Okay. So that should fix our problems. And it does look like I forgot to add my my semicolons. All right, and there you have it. 3 3 4 4 5 5 5 5 4 4 3 3. So these are how these operators work, and this is how we can overload them. And so pretty much in these last 3 classes, we've covered almost most of the operators. There's a few that we haven't done, but we did do a Boolean operator. We did do the insertion and the extraction. We did do multiplication and addition. We did the brackets. We did the assignment. We did the plus plus and the minus minus. What else did we get? Maybe that was it. Yeah, that was it. But it should make sense, right? So I hope that you guys got something from this. I hope that, of course, you can follow along with me here, at least as I type it in front of you. I know that, watching the code can be kind of sleep-inducing, but at least you have it, to reference. And if you were able to follow at all, then I'm sure that you can come back and check. The video will be on YouTube. And hopefully you know that operators are very helpful to us. They're very cool tools to use in C++. So I will catch you guys next time for templates. We're going to begin with templates. Please do the assignment. Ask me some questions, all the questions. Even if your code is not compiling, I want to see it. Let me help you so we can get some points. I'll be grading the extra credit soon. And that's that. So you're welcome to leave. Thanks for coming to the stream. Office hours are in 15 minutes. I'll be there. And I'll catch you guys next time.